So first of all, you tell me whether it is a 10 to 11 class or 10 to 12 class. It's 1 hour or 2 hour class.
Sir, 1 hour, 10 to 11.
Okay, 10 to 11. Okay, thank you. So now we'll. So you have already done relation, I think. Sir has already taught you relations. Is it? So have you done topic relation, like what is relation, type of relations? Have you done this? You can tell yes or no. You may unmute everyone, है ना?
Yes,
You are,
sir.
so you have
Yes, sir.
done. So we will do revision. Okay. So I will be doing revision. I will be writing the question and you have to tell answer. So everyone, please sit with the pen and paper and you try it, because in the exam they will also ask you the similar questions. So you will have that. Okay. So like 1 minute. So let me share the screen. One minute. Let me change the background. Okay, so we will be starting relation. So first of all, anyone tell me what is definition of relation? How do you define relation? Anyone? So you can unmute and tell. How do you define relation? So like if I say R is a relation from set A to set B. So set is a family. So we are defining a relation from set A to set B. So how do you define relation? So what is the definition? Anyone?
The relations can be described as a collection of ordered pairs.
Right? In what way? So like collection of order pairs, yes, any pairs or some specific order pairs. So if I write relation R is from A to B, means R must be a subset of A cross B. And A cross B is a collection of order pairs. So you know this thing, that A cross B is a set of order pairs AB such that A belongs to capital A and B belongs to capital B. And since R is a subset, so obviously R relation will contain the order pairs from the set AB that will satisfy the condition of the relation. So usually the mathematical definition is like any subset of A cross B is a relation from set A to set B. So if you write in word, so in word we write any subset of A cross B is a relation. So my handwriting is very good, so you bear with that. So any subset of A cross B is a relation from set A to set B. Okay. Any subset of A cross B is called a relation from set A to set B. So this is the definition of relation. Okay, now I will come to types. So how many types you know? Like in the syllabus you have been taught. So tell me, what are the types you know already? So anyone, please name the types of relations. You know?
Sir, reflexive, symmetric, transitive.
Yes, yes. So reflexive relation, yeah, symmetric relation, and transitive relation. Okay. So just we are doing revision. Okay. So this will help you in exam. Yeah. So what is the fourth type or collective? So or relation which is reflexive, symmetric, transitive, all. So what do you say that relation? What is the name of that relation?
Equivalence plus.
Equivalence reaction.
Equivalence relation. So equivalence relation. Type of relation is equivalence relation. Actually, equivalence relation creates equivalence class. That is another thing. So equivalence relation. Okay. So this is equivalence relation. Okay. So one by one we'll see the definition. So anyone please define reflexive relation. So like please try everyone. Okay. If you will not be able to do, then I will do. So reflexive relation. One minute. Okay. So now anyone define what is reflexive relation? How to define? So suppose R is a relation from A to B. So when can we say this relation is reflexive? So R may be like suppose order pair A B such that some restriction will be there. So how will you check this relation is reflexive or not? So what is definition of reflexive? Yeah, tell me anyone what is definition of reflexive relation? No one knows. बताओ भाई किसी को भी नहीं पता रिफ्लेक्सिव रिलेशन क्या होता है? हम्म तुमने सर ने पढ़ाया है ना? जस्ट यू रिकॉल द डेफिनेशन. अगर याद नहीं है तो नोटबुक को देख के बताओ एटलीस्ट यू टेल सो दैट. बताओ नोटबुक से देख के बताओ अगर याद नहीं है तो लाइक इफ हैव एनी.
That it is a relation of elements of a set, that each element of set is related to itself.
Right. So in word if you write so like a relation on, so actually like types we define on set A, so we'll not write A to B. So we usually we define the relation, this types is defined for the relation from A to A. Okay, so relation from A to A, so or we call it relation on set A. So you have seen this word relation on set A. So we define this and then based on this we define these types. Okay, so we are just looking relations between elements of a set. So R is a relation from A to A. So that we are talking. A B and here will be some restrictions and obviously A B both will belong to capital A. And so a relation on set A is reflexive if a relation on set A is reflexive if every element of set A is related to itself. So okay, so this every element of set A is related to itself. This is the definition. If every element of in mathematically if you want to write, so you will write like that. That is, if A belongs to elements capital set A, so small a is element, capital A is set. So small a belongs to capital A, then A comma A will belong to R for all A belongs to A like that. Okay. So if A is an element of A, then A must be related to A itself. I mean, A must be related to A. So every element must be related to itself. So I will write one example, and you have to tell whether it is reflexive or not. So for example, so I will take example from your book only, the notes only. So the example is first I will give you a set A. So set A is 1, 2, 3, 4. 1, 2, 3, 4, and R I define as the collection of order pairs 2, 1, 3, 1, Uh, 2131, 2233, 4142. Okay, so I will make it one day. So tell me, is this relation reflexive? Can we say this relation is reflexive? So let me call it R1. R1 is the first relation, like I'm talking about first part. So is it reflexive?
No, sir.
No, sir.
No. Why it is not reflexive?
All the elements should have a relation with itself.
Itself. So which one do not have relation with itself?
One and two.
Four does not have and one does not have.
Yes. So every element must be related with itself. So one. So two is related to two. Three is related to three. But there must be one. There must be four. So one is not available. Four is not available. That's why it is not reflexive. So this relation is not reflexive. Okay. Second one, if I write like R2 as, suppose 11 22 33 44 and 42, suppose like this. So is it reflexive now?
Yes,
Yes,
sir.
sir.
So yes, this is reflexive because 1 is related to 1, 2 is related to 2, 3 is related to 3, and 4 is related to 4. So that's why this is reflexive relation. This is reflexive relation. Okay, so if 4 2 is there or not there, it will not affect, okay, the reflexibility. So for the reflexive relation only you need to see that whether every element is related to itself or not. Okay, so now this is the, okay, I will write some theoretical question, like one more question I will write. So suppose third question is, r if I write a comma b such that 1 plus ab is more than 0. So is this relation reflexive? A set you take the same. So you take same set, one, two, three, four. Now you tell this relation is reflexive or not. So this relation is reflexive or not.
Yes, sir, reflexive.
How do you see that?
Yes, sir.
So if we take A as 1 and B as 1, the condition will be satisfied. Similarly, if we take 2, 3, and 4, it will be satisfied.
Right. So what do we check for reflexivity theoretically? So like this smaller set, that's why you checked for each element separately. But like if this set is suppose has infinite element, so you will not check for each element. Then you write in general, like I'm writing here. See. So we need to check whether AA belongs to R for all A belongs to A. Okay, so I need to check that. So we assume, okay, so like we assume that let small a belongs to capital A, and now we need to check this one whether this is true or false. Okay, so here in place of AB, what you are seeing here, A is related to B if 1 plus AB is more than 0. So 1 plus, now we need to A means in place of B we need to put A. So 1 plus A into A, so that will be 1 plus A square, and we know the property of A square. A square is never negative. So 1 plus A square will also be never negative, or it will be positive, always more than 0. So means 1 plus A into A is more than 0. This implies A comma A will belong to R for all A belongs to A. And this is enough to say, therefore R is reflexive. So whatever set we choose, like A has 1 2 3 4, but whatever set you will take there, it will always be reflexive. Okay, if A, in place of A, if you have set of real numbers, set of natural numbers, set of integers, still this will be reflexive with this on A. Okay, fine. So this was reflexive. Now we come to next type. So next type is symmetric relation. So second type we have symmetric relation. Symmetric relation. Now anyone tell the definition of symmetric relation? What is symmetric relation?
Sir, a relation in which the first element related to another element and vice versa.
Okay, so you may write like that, like if AB belongs to R, so meaning is A is related to B, then then is implies BA belongs to R for all AB belongs to A. So if this happens, then you need to check whether this happens or not. If it is happening, then it is symmetric. So if A is related to B and B is related to A, so that is symmetric. Okay. So now, so this is AB belongs to R, then BA belongs to R. This is a definition. What you can say is like, right? If A is related to B and B is related to A, then B is related to A, then we call it symmetric relation. So for example, see the same examples on last three examples. So do you see the first relation is a symmetric relation? Now we check for this example whether this relation is symmetric or not.
No, sir.
Why do you see it is not symmetric? So what is the reason behind it is not a symmetric?
It is only related to the next element. Like if one is with 2 comma 1, then it should also have 3 comma 1 and 4 comma 3 comma 2 should also be there, and 4 comma 3 should also be there.
No. It is not saying like that. It is saying that if A is related to B, then B should be related to A. Okay. So like for example, if 2 1 is here, right? 2 1 is here. So if means assumption, you assume, and then means you will prove or check. So like 2 1 is here. So 2 1 is here. So if 2 1 is here, then what will you look for? If 2 1 is here, then for checking the symmetricity, what will you look for?
1 and 2.
1 and
1,
2.
2.
So is there any 1 2? Do you see any 1 2 here?
No.
No,
No.
sir.
So that's why this relation is not symmetric. So one example is enough to say no. No means wrong. If you want to prove something wrong in mathematics, so just one example is enough. So if you find any one example against the definition, means that is wrong. So like 2 1 is here and then 1 2 is not here. So this is enough to say this is not symmetric. We don't have to look to any other element now. Okay. So this is not symmetric. Not symmetric. Okay. Now look here. So do you see this is symmetric? Second example, this one. So is it
No, sir.
so why it is not symmetric?
Sir, 2 comma 4 is not there.
Yes, 2 comma 4 is not there. So like 4 2 is here. So then 2 4 must be there. Okay. So for every AB which is in the relation, you must get BA. Then it is symmetric. So 4 2 is here and 2 4 is not here, so it is not symmetrical here. Okay. Now look for this example. Third one. Is it symmetric? Is it symmetric or not?
Yes, sir, symmetric.
Okay. So here is what like what do you see, you will assume AB belongs to that. So see how will you check? So like we assume that AB belongs to R. So if means assumption. Okay. So we assume that, so if AB belongs to R, I suppose let AB belongs to R. Now I need to check that will BA belong to R or not. If BA belongs to R for all AB belongs to R, then we call it symmetric. So AB belongs to R means what? AB belongs to relation R. So R3 I'm writing just R. So AB belongs to R, then the condition is this. So this means 1 plus AB is more than 0. Okay. And now to check BA belongs to R, so you will interchange AB. No? So like what do you do in symmetricity? You must interchange and check. So let's interchange. So if I write AB and BA interchange, then it will become 1 plus BA more than 0. So if you prove that 1 plus BA more than 0, then you can say like BA belongs to R and then it is symmetric. So 1 plus AB is same as 1 plus BA because no, we know the mathematical rule. A into B will produce same as B into A. So they are nothing not different. And AB and B are same in mathematics. So 1 plus AB and 1 plus BA both are same. So that is more than 0. So writing this and writing this both are same thing. But according to this relation, AB belongs to R, then 1 plus AB belongs more than 0. And you write 1 plus BA more than 0 means B comma A belongs to R. So what you proved? You started with this assuming and you proved this. And that is enough to say. Actually, we wrote the general proof. We are not checking for each element. So that means it is symmetric. So yes, it is symmetric. So relation R is symmetric. Like in the third part, this is symmetric. Okay, fine. So now let's go for next definition. So third type is transitive relation. Transitive relation. So now you tell the definition of transitive relation.
If set AB belongs to R and set BC belongs to R, then set AC should also belong to R.
Okay. So like you will assume if A is related to B, B is related to C, then you need to check whether A is related to C. Okay. For all such AB, C belongs to A. So if this happens, only then you have to check this. No. So so if A is related to B and B is related to C, then C is related to A. So those who are joining now, is it the time to join? It is half an hour late. Okay. So transitive relation. So AB belongs to R, BC belongs to R, then AC belongs to R. This is a definition. So now let's come to the again that examples. So check whether this is transitive, the first one. So check for the first part. Is it transitive relation? Yes, yes. Check whether this example, the first example, is transitive or not. Is it transitive? Check for transitivity. So no one is able to check. Suppose in exam they ask you this, like how will they ask the questions? Like this, he will give you this example, and options will be, na, reflexive but not symmetric, symmetric but not reflexive, transitive but not like that in option. So suppose transitive is one of the options. So what will you think? Take. It's transitive or not transitive. How will you check? Okay, so you can respond that you are not able to check. So what is the problem? You can tell me. I mean, why are you not able to answer? Why are you not able to answer?
Yes, sir, it is transitive.
Okay, it is transitive. So how did you check?
So, like taking the first two sets, we can say 2 comma 1 and 3 comma 1. If so, 2 comma 1 should also belong to the relation, which is all.
No, no, no. You will not check like that. So A, B, and B, C. So you notice that this B must be common. So when you select two order pairs, like suppose A का friend B है और B का friend C है, तो ये हमने अज्यूम किया, या हम पहले ऐसा पेयर ढूंढेंगे. अगर ऐसा होगा, उस केस में ये चेक करना है हमें कि क्या ए का फ्रेंड सी है. अगर ए का फ्रेंड सी होगा तो ट्रांजिटिव है, अदरवाइज नहीं है ट्रांजिटिव. So same thing is here. A is related to B and B is related to C. So you have to check now whether AC belongs to R. R means they are related. So A and B are related, B and C are related. Then you need to check whether A and C are related or not. Okay. So you need to check it.
No, sir, then it is not transitive.
How did you decide?
The 2 comma 1 is there, but we do not have 1 comma 2.
But
1 comma or any number.
you have to
Just to.
yes, you are trying good, but you have to search check for all. So see, I'm telling you one hint. Check for this
Sir, we
4
can
to,
take 2 comma 2 and 2 comma 1.
you may take, but it will not give you any profit. Like 2 2 3 3, this will not help you in transitivity. Like yes, you are right. 2 2, and if you take 2 1, so 2 2 is related to 2, and 2 is related to 1. So at the end you will check CA. Check A is 2 and C is 1. 2 1, 2 1 is already there. So in transitivity, this 2 2 3 3, this type of pairs will not help you, because like at last AC will be the same which was this AB, or like that you'll get. So now I'm giving a hint. Check 4 2 and 2 1. 4 2 is there, yes or no? 4 2 is there in the relation, yes. And 2 1 is there in the relation, yes. So 4 is related to 2 and 2 is related to 1. So I got A related to B, B related to C. B is common. You just note it. B is common. So A related to B, B related to C. So now you check whether A is related to C or not. So 4 is related to 1. True or false?
True, sir.
4 1 is there. Oh, check carefully. 4 1 is here. Check carefully. Is it? So for 2, 4 related to 2, 2 related to 1, then here 4 related to 1. So these two are in relation and this is also in relation. So according to this example, this is transitive. But don't be in hurry because example can never prove a general result. So you have to check for the all example or you have to prove in general. So we have to look for the other examples also, like is there any other pair A, B and B, C? So you can go for that. So like here, like 2 1 was there, so you will search for those elements starting with 1. There no one is starting with 1. Like here 3 1, so you will check for those starting with 1. There is no one, so AB is there but BC is not there, so you will not check. Now like 2 2, you ignore these thing in transitivity. 2 2 3 3, this helps only in reflexivity. It will now not help you in symmetric or transitive. 4 1, so again 4 1 is there, so we'll check whether anything starts with 1. No, here is 4 2. So 4 2. Okay, so we'll check whether anything starts with 2. Yes, so it was 2 1. So 4 2 and 2 1. So AB BC. So AC is 4 1. 4 1 is there. Yes. So according to this, you are okay with transitivity. Now we'll check for all other examples. Like 4 2 is there and 2 2 is there. If you want to check, 4 2 is there and 2 2 is there. So pair is what? AB 42 BC 22. So it will give you 42 only. Like A and C if you write 4222. So AB BC. So AC is 42 only. And 42 only. 42 is actually already there because that's why I'm saying like 2 2 3 3 1 1. This will not help you in transit because they will produce one of them. Obviously they are inside that element. Like they were suggesting one more, like 3 3 is there and 3 1 is there, or 2 2 is there, 2 1 is there. So we may go for that also. Check 2 2 is there and 2 1 is there. So 2 2, A related to B, B related to C. So AC will be 2 1 only, that is already there. So that will not help you much, like if any one pair is same. 2 2. Anyway, this relation is transitive. Just this is enough because there is no such pair A B B C where A B are different, B C are different. So AC belongs to R. So like 4 2 were there, 2 1 was there, the 4 1 is there. Yes, this is transitive. So this is transitive, A part. But transitivity is something more difficult than the reflexive or symmetric. Okay, so you have to take care of that. Carefully, you have to see. Okay, come with this example. Now see the second part. Do you think it is? So I'm telling about this R2. Elements are 1 1, 2 2, 3 3, 4 4, 4 2. So do you see this is transitive?
Yes, sir.
How do you see it is transitive?
The 4 comma 2 is there and 2
Hmm.
comma 2 is there.
Hmm.
So AC is 4 comma 2 which we have already.
Okay, that is also good way. That is also fine. Yes, this is transitive, like you said, is also fine way. So this is transitive. 4 2 and 2 2. So there is no such other pair, like 4 2 is there and 2 2 is there. 4 2 2 2. 4 related to 2 related to 4 related to. That is there only. But if you don't look for these elements for transitivity, suppose we don't want to look the elements where both numbers are same. Okay, in the order pair both numbers are same. So 4 2 is alone. So in that case this is exception. So in that case this will be transitive by default. For example, like what I want to convey, if I write one example, suppose fourth example. So A is a set containing like 1, 2, 3, 4, like everything. And R if I write only 4, 2. So now if I ask you, chalo, let's start with 3, all three of them. So first you tell me whether it is reflexive or not. Check for reflexivity. Is it reflexive? Yes or no?
No, sir.
No. Why?
So 4 comma 4 should be there
4
or
comma 4 should be
something
there,
else.
1 1 will be there, 2 2 should be there, 3 3 should be there. Yeah.
Yes, sir.
Okay. Is it symmetric?
No, sir.
Why it is not symmetric?
So 2 comma 4 should be there.
Yes.
Similarly, the other side
Okay.
should be there.
Okay. Do you see it is transitive?
No, sir.
Why do you see it is not?
So we need two sets like A comma B and B comma C. But here we only have A comma B.
Hmm. So actually, you cannot prove it is not transitive. That's why it is transitive. So this is exceptional case. So there is a logic behind that. Like if what we were writing definition, AB belongs to R, BC belongs to R, then we were checking AC belongs to R. If you cannot find AB and BC, then you cannot tell about the conclusion. So conclusion will be true in that case, according to mathematical rule. So for example, statement is P implies Q. Just try to understand this. So P is one statement implies if P then Q. We also write like if P then Q. So if you cannot decide about P, okay, like in the P implies Q, what do we do? That if P is true, so there is a mathematical logic concept, and there we see that you can go for this truth table of this. So if P you cannot tell, P is not finding, like you are not finding AB and BC. If you are not getting AB and BC itself, then how will you check for AC? In that case, by default, it will be true. This statement will be true. Okay. So I don't want to go a theory of that because it will take again time. So there is a concept mathematical reasoning. If you have gone through, or it will be in syllabus, you can go for that. Truth table of P implies Q. Then you will understand. So logically, I'm telling what. Suppose so. This point you have to remember in exam. If they ask you, just remember. Like for the transitivity, you need AB and BC, and then you will check AC. But like only AB is there. There is no BC. So in that case, you cannot say AC is not there. Okay. So if you cannot prove something wrong, that will be true. Here in mathematics, it is like that. So so here is what, like only one element is there. So whenever you find single element, only one order pair is there. So this type of relation will always be transitive. Just you remember that. If you have only one element in the relation, anywhere if you find only one element in the relation, that will be always transitive. ये लाइन तुम याद रखना, इससे ही हो जाएगा, ज़्यादा दिमाग नहीं लगाना है. अगर एक ही एलिमेंट है इसमें, तो ये हमेशा ट्रांजिटिव होगा. ठीक है, ये ध्यान रखना तुम्हें. इसके पीछे लॉजिकल कॉन्सेप्ट्स हैं जो कि मुझे एक्सप्लेन करना पड़ेगा, सो आई डोंट वांट टू गो इनटू दैट. Okay, so whenever you find single element in a relation, single order pair in a relation, that will be always transitive. Okay, so that's, do you remember? Because for to check transitivity you need two pairs at least. So if it is one, then you by default it is an exceptional case you call, or you call it a voids case. Okay, or there is a theory behind that, so according to that it is transitive. Okay. Now, so you got reflexive symmetric transitive. Now there is one more relation. You know already equivalence relation, right? So equivalence relation. So you know equivalence relation. So what is equivalence relation?
So when a relation is symmetric, transitive, and reflexive, then it is known as equivalence relation.
Yes. So R is reflexive, symmetric, and transitive simultaneously. मतलब at a point, all three relations satisfy all three conditions. Transitivity है ना, simultaneously. Then it is equivalence relation. Then R is equivalence relation. So if it is reflexive, symmetric, transitive, all, then we call it this word you mean, all right? This then we call it equivalence relation. Okay, so let me write one example. So the set we have, suppose So I may take example from this only. Okay, so let me take. So set A as I'm taking natural number, suppose 1, 2, 3, 4, 5, and so on. Or you may take integers. So integers are what? 0 plus minus 1 plus minus 2 plus minus 3 and so on. Okay, and R I'm defining relation A comma B such that A minus B belongs to, yeah, A minus B is an integer, is an, yeah, is an even number, suppose this is even integer. Okay, so now you check whether it is, first check whether it is reflexive, check whether it is symmetric, check whether it is transitive, check for one by one, and then can we say it is equivalence? So these four questions you have. So options are yes or no. Okay, so you have to choose one. Yes, no, yes, no, you have to choose. Okay, so you select one of them. Tell. So first you check for reflexive, whether it is reflexive or not. Is it reflexive? Okay, Partha Das. So is it the right time to join the class? What was the time of class joining? Are you a student? Okay, first check it. Quickly check it. Is it reflexive? Yes or no?
Yes, it is reflexive.
So how did you get that?
So by taking examples,
Examples of general you can also say. So what do we check in reflexive? A, whether A belongs to R or not. So A minus A, what will be A minus A? 0. So A minus A is 0. So like A minus A is 0. And can we say 0 is even? Yes or no? 0 is even or not? 0 is even integer.
yes, sir.
So yes, 0 is even integer, and that's why, so if A minus B is even number, we call A related to B. So A minus A is 0, that's why we call A belongs to R, and A belongs to R means R is reflexive. That is the definition. So R is reflexive. Or by example, you can also do 0 minus 0, 0, 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0, minus 1, minus 1, 0. So all are even enough. So if A minus B is even, we call A related to B. So here A minus A is 0, 0 is even. So that's why this is reflexive relation. Okay, so what about symmetric?
Yes, sir.
So in symmetric, what you'll check, you start assuming that AB belongs to R in symmetric. So means you will assume A minus B is even. So if A minus B is even, so can you say B minus A will also be even? Yes. Like 1 minus 3, this is minus 2 is even. So 3 minus 1, that will be 2, also even. So if A minus B is even, so B minus A will also be even. So we only need even, whether it is even or not. Yes. So A minus B even. This means that BA belongs to R, and that is yes. So this is symmetric also. Okay. Is it transitive? So is it transitive?
Yes, sir.
So it is transitive also. Okay. So for transitivity, what do you do? For the transitivity, you do that AB belongs to R, BC belongs to R. This you assume, and then you check whether AC belongs to R or not. So like A belongs to R means what? A minus B is even. BC belongs to R means what? B minus C is even. And then you know sum of two even number is even always. 2 plus 2 4, 2 plus 4 6, 6 plus 8 14. So if you add two even integers, you will get even integers only. So since A minus B is even, B minus C is even, if you add both, so A minus B plus B minus C, so that you will get A minus C, and that is also even, because sum of two even is even. So A minus C is even, and it want to say that AC belongs to R. If A minus C is means AC belongs to R. So A related to B, B related to C, and A related to C. So means, so this means that it is transitive, and transitive means yes, it is transitive, and it is reflexive, symmetric, transitive also. It is equivalence relation. Okay. Okay, so today we discussed what is relation definition, then what are types like reflexive, symmetric, transitive, and equivalence. There is one more type, anti-symmetric, so that we'll see in next class. Or you have already seen, just we were doing revision. Okay, so here I will stop today, and thank you so much.